Once circuits have been defined and connected to a panel, you need to wire the circuit in order to show how the electrical components will be connected. Revit automatically calculates wire sizes for you based on the settings specified in the electrical settings. Revit calculates the wire sizes for power circuits based on the size specified for circuit protection, voltage drop calculation, and correction factor. Wire sizes are automatically sized to maintain a voltage drop of less than 3% for branch circuits and 2% for feeder circuits at the outlet furthest from the source. That is, the circuit load determines the overcurrent protection required, which, when specified, then determines the wire sizes required for hot conductors, neutral conductors, and ground conductors. Revit also creates a temporary wiring layout for each circuit created. You can use the temporary wiring to generate wiring for the circuits defined in your model. For example, in this project, the electrical fixtures in the south portion of the building have been assigned to circuits. When I select an electrical fixture, an electrical circuit's contextual ribbon appears next to the electrical fixture's contextual ribbon. I'll switch to the electrical circuit's contextual ribbon. When I do, you can see a dashed line connecting the electrical fixtures. There is also a dashed home run symbol pointing to the panel. In order to convert the temporary wiring to actual wires, first deselect everything by clicking in blank space. Then hover your cursor over one of the electrical fixtures and press Tab once. When you do, the temporary wiring for the circuit once again appears. Simply click to select the circuit. Realize that once you click, the ribbon changes to the Modify Electrical Circuits contextual ribbon, and the Properties palette populates with the properties of the circuit. When I scroll to the bottom of the Properties palette, you can see the wire type, which can be changed, along with the wire size that Revit has calculated for this circuit. In the contextual ribbon, the System Tools panel is the same panel that appeared on the Electrical Circuits contextual ribbon before. However, a Convert to Wire panel also appears. There are two tools here, Arc Wire and Chamfered Wire. The Arc Wire tool will convert the circuit to arc wiring, while the Chamfered Wire tool will convert the circuit to chamfered wiring. Additionally, pay attention to the arc wire and chamfered wire icons in the drawing area. These are the same tools as the ones in the Convert to Wire panel. In the contextual ribbon, I'll click Arc Wire. When I do, wires are automatically created. They are also selected. In the Properties palette, you can see the properties for the wires. As you can see, they match the wiring properties for the circuit that we looked at earlier. If needed, you can change the type in the type selector after they have been created. I'll click in blank space to deselect the wires. As you can see, wiring in Revit is schematic. You do not have to model actual wires running in the walls and above ceilings. Additionally, wire does not behave like other model elements. For example, if we had another Level 1 plan showing the power system, the electrical fixtures and panel boards would appear, but the wiring would not appear unless the view was dependent on the current view. Even though wires is a model category, the elements behave more like annotation objects. Therefore, they must be added in each view in which they should appear. Recall that Revit automatically sizes wire according to the load and voltage drop. But if you do not agree with the sizes, you can change the circuit rating in order to adjust the wire size. For example, when I hover over an element in the circuit and press Tab twice, the circuit highlights and I can click to select it. Then, in the Properties palette, when I scroll down to the wire size parameter, you can see that the size cannot be modified. There are actually 3 sizes here. From left to right, these sizes are for the hot conductor, neutral conductor, and ground conductor. To modify these sizes, you can scroll up to the rating parameter and change this value. First, I would recommend reading the wire sizing documentation on the Autodesk Wiki help site to better understand how Revit calculates these sizes. Then you can calculate the values needed to get the correct wire sizes, rather than guessing and checking. Also, you should look at the wiring settings in the electrical settings dialog. I'll click Modify to deselect the circuit. Then I'll click the dialog launcher on the electrical panel of the Systems ribbon to open the electrical settings dialog. When I select Wiring on the left, the wiring settings appear in the panel on the right. Here, you can adjust parameters such as the tick marks. For example, I'll click in the ground wire tick mark value field, expand the drop-down, and choose Short Wire Tick Mark. You should also check the wire sizes, correction factor, ground conductors, wiring types, voltage definitions, and distribution systems to make sure that these settings match your company's standards and the applicable building codes for your project. I'll click OK to close the dialog. Back in the drawing area, you can see that the wiring tick marks have updated. I'll pan over to the next room. To wire these fixtures, hover your cursor over an electrical fixture, press Tab, and then click. This time, click Chamfered Wire in the contextual ribbon. See how the wiring is different? If needed, you can modify this after the wires have been created. With the wires still selected, pay attention to the type parameter in the Properties palette. It is currently set to chamfer. I'll click in this field and change it to arc. I'll pan over to the next room and select the circuit. This time, I'll click the arc icon in the drawing area. When I do, the wiring is created. If needed, you can select an individual wire or home run to modify the wire. With a wire selected, there is a grip at each end as well as a grip in the center. You can use these controls to move the wire. Also, there is a plus and minus icon. These can be used to modify the number of hot conductors. Lastly, I'll pan over to the next room. There is also a wire tool that can be used to create wire. On the Systems ribbon, in the electrical panel, expand the Wire Split button. In addition to the arc wire and chamfered wire tools, there is a spline wire tool. You can use this tool to create splined wire runs. I'll click to activate this tool. When I do, Revit is prompting me to click to enter the wire start point. When I hover over an electrical fixture near the wall, I can see an electrical connector snap. I'll click on that snap to place the wire start point. The next click is to place a wire control point, so I'll click near the center of two fixtures. Then I'll click to place the wire end point at the connector of another fixture. Once I do, realize that the wire end point locations move so that they do not cover up the receptacle symbol. I'll continue connecting fixtures. When using the spline wire tool, you can place more than one wire control point if needed, and you can also press spacebar to toggle chain mode on and off. To place a home run, press Enter after you have placed the start point and at least one control point. I'll click Modify to end the command. As you can see, there are numerous options to wire circuits, and Revit provides settings that you can use to adjust wire sizes.